Welcome to another edition of the Modern Agile Show. I am here with my friend Arlo Belshee. We're at Deliver Agile in Austin, Texas.
Hello.
Hello and welcome. Well, gosh, it's a pleasure to be here with you. Arlo, you gave a wonderful talk yesterday. What was it called? What was it about?
It was Mastering Legacy Code, and it's about preventing bugs you don't know about in code you can't test.
Wonderful. Code you can't test, yes. Yeah. So lots of code written without tests in mind, right?
Yep.
And I took away a lot from that. I took away the fact that you've come up with a recipe for safe, very, very safe refactoring. Can you talk about that?
Sure. Yeah. So this is for that catch-22 problem of you can't refactor. People think you can't refactor code without tests, and it's actually true that you can't test code without refactoring it. But people get trapped in that catch-22, and this breaks it because there are safe ways to do refactorings that don't depend on having a test suite in place.
Aha, so go into an old legacy piece of code with never having any automated tests for it, but safely make design transformations.
Right.
Awesome.
Yeah.
People need this.
Yes. Yeah. So yeah, we talked about a number of things there. I showed the extract method refactoring recipe that we developed at Tableaux. And it's a for humans script, and you go through and it literally says, copy and paste these 7 characters and those 7 characters and put them here, right? It is intended to be dirt stupid foolproof. And we're finding at Tableaux that you can refactor code, and people are doing this, and there were bugs in the script at one point. That caused bugs, but we found those. We fixed the script, did that, and at this point, it seems like the script is pretty bulletproof.
Yeah.
And people are refactoring. The only bugs we see are when people don't follow the script.
Right.
Take shortcuts.
So how does this differ from using a tool like extract method from a tool like IntelliJ or ReSharper or whatever?
So the main way it differs is that it's in C++ or JavaScript.
Ah, okay. so you can do this in those languages that don't have very fully developed refactoring tools.
Exactly. And ReSharper is adding support for C++, and in 3 years you'll be able to do extract method there, and it won't have any bugs. But right now it still has bugs, and so we can't use it in these ways.
So your formula is foolproof, and you can apply it in languages like C++ and JavaScript and other languages that don't have good tooling.
Well, you can explicitly apply this in C++ and JavaScript.
Okay. And what about Java? I mean, like, let's say you're not using an IDE, and
someone could create a new recipe that would work for Java, but this recipe wouldn't.
Okay, so this recipe is language specific?
Yes.
Oh,
yeah.
Okay.
So there's the general recipes that Fowler has,
Yes.
and those ones work across all languages, but in order to do so, they have to be non-specific on a number of things and depend on human judgment, and so they're not foolproof, right? Whereas these ones are designed to be absolutely foolproof, no human judgment involved, but in order to do that, they have to be specific to exactly the language that you're working on.
Okay, fair enough. So the idea then, and I recall you talking a lot about leaning on the compiler. Can you say a little bit more about that?
Yeah. So the big problem that shows up with refactoring is how do you prevent mistakes? Even if we're using a recipe and it's just like paste these 7 characters in, you could still screw it up somehow, right? The scope of errors is smaller, but they're still there. And so how do you detect and prevent those? I don't use tests, and there's actually a reason that I don't use tests. It's not just that the code is untestable, it's actually that tests can't give me the level of assurity and safety that I'm looking for. And we can talk about that in a moment.
Right.
But so what I do is I use static analysis and the compiler to do it, because I need something that will verify that code is absolutely bug for bug compatible with whatever it used to be. I didn't accidentally fix a defect. I didn't accidentally introduce a defect. I know it's identical.
Yeah.
And the rules of the language allow you to define what those things are, and the compiler is a machine that interprets the rules of the language. And so if you can use the type system correctly or use other things, you can validate.
So it's very, very micro. I mean, you are making the tiniest change compiling, to see that that's what I noticed in your talk, right?
Yeah.
You demonstrated this, and it seems extraordinarily safe.
Yeah. Yeah, extract method is about 9 steps, and there's one step where you're getting the return value correct. Another step where you're introducing the name of the function. Another step, like they're not big steps.
Yes, yes, very good. So this is good news because people now once you do that, do you see people coming back and writing automated tests?
Sure. Automated tests are still very, very useful. They're just not needed for supporting refactoring. They're needed for all sorts of other things.
Yes.
And so it's because I've made refactoring absolutely safe. It changes the economics, and you can refactor in more times and more places. I can read by refactoring. The talk that I gave last year was based on before we had published this, but still doing this, right?
And that's when you're reading code, you might not understand something, and you apply this safe mechanical formula to then extract something out or make something more readable and understandable.
Yeah, or I have an insight, I encode it into the name of the thing, right? And a lot of renames, a lot of extracts, a lot of just like, give me a name and name it, right?
Sure.
And so, yeah, doing a bunch of that, or if I'm implementing a new feature, I definitely need the tests as I go along, and I might need to do some design changes in order to make that easier and implement the feature. And the code might not be fully tested, or certainly isn't for the testable for exactly what I need, so I need to do some safe refactorings along the way, right?
Yeah, it's really nice evolution. I mean, it really is, because I mean, of course, I have a lot of code bases that have lots of automated tests around them, and it's such a pleasure to refactor in those because, you make a mistake. If the tests are well written, they'll catch a lot of things, not everything.
They won't catch everything.
They won't catch everything.
And so part of this is from my time working at Microsoft. And working at Microsoft.
Yeah, you told me about that once.
Yeah, bug for bug compatible.
Yeah,
like,
so as I recall you saying, there are versions of Microsoft Word that have to have the bugs in them. You cannot fix those bugs.
You cannot.
Because
So I was working in the database group, and we were producing the OData spec, and there were some oddities, and we just simplified that part of the spec. And then we heard back from the SQL Server group that if the spec was written that way, then SQL Server couldn't support it, and we asked why. And it's because there was a bug written in the first version of Foxpro, back before Microsoft acquired it, that was used in developing a system at a major automotive company, one of the big ones, that source code was lost for about 15 years ago, and is a major production system running a core important part of their business, and every single database that is built on anything that they could have ported forward from that version of Foxpro needs to exhibit this behavior.
The buggy behavior.
The buggy behavior,
Yeah.
and be able to link against those binaries that were the last ones they could compile 15 years ago when they still had source.
So when we say when we're saying Microsoft cannot fix the bug, it's not a question of they're able to fix the bug. It's just that
they would lose $1.5 billion in annual revenue if they fix that bug.
Yeah. So you're
So they won't.
So refactoring in that kind of code base is pretty hairy because you have to know exactly what is allowed and what's not allowed.
Right. Yeah.
What is safe?
Yeah, it's really all about safety. Yeah, that whole thing. Yeah.
Yes. Make safety a prerequisite. So that is a core part of what you're doing here.
Yeah.
In helping develop this technique of safe refactoring. It's a really big deal because
it is.
So many people claim, I literally was just talking to a client an hour ago, possible new client, and they're like, well, we don't know because the developers are saying that we can't write tests because the code's not written for tests, but we're afraid to refactor because we don't have tests.
Yeah.
What you're saying is don't be afraid to refactor, follow these formulas that are safe, and it will allow you to change the design of the code safely, such that you could probably then start writing tests.
Yeah, and in fact, we had a number of good conversations around the read by refactoring and what is the level of safety we need. That Jay Basuzzi simplified down to a nice blog post out there that's tests are neither necessary nor sufficient for refactoring. And when we're going for that bug for bug compatibility, like I need to ensure that particular bug is one that Microsoft knows about and can't fix. But there are a number of other customer bugs that have been in the product for 10 or 15 years that nobody at Microsoft knows about, but that Microsoft would also lose hundreds of millions of dollars of sales if they were to accidentally fix. So you need to ensure that you never fix a bug that you don't know exists.
Yes.
And how are you going to write a test for that? By definition, you cannot write a test for it because you don't know it exists.
Yeah.
Right?
Yeah.
And so that's why we need this level of safety. And then once you have this, like the modern Agile stuff, it's not that like there may be some reason that you need that safety and you create it, but then you find making it a prerequisite really changes the whole economics.
Right.
And it's not just that you do it in that sort of a system, but once you have something that safe, you want to do a design change, you know you won't make any bugs.
Yeah, that's a wonderful
there's
feeling.
Just no fallout possible.
Yeah. and so it seems as if you're almost like using the compiler. You might have said something this in your talk, using the compiler as the safety net or something like that.
I'm using the recipe as the main safety net, and then it's really you're using your tools.
Yes.
And the recipe is one tool. The compiler is another tool, and there are other tools that you might use.
Okay.
Anything that's able to do some language-based static analysis or whatever you've got.
Okay, so it does require some sort of level of type safety, whether that's, you mentioned TypeScript for JavaScript.
Yep.
You've got to be in a type-safe environment.
Yeah, I don't know how to do it for Python or Ruby. Like
Okay.
just the tooling isn't there because the language is a little too dynamic and flexible. If you aren't using certain parts of the language would be, Python in particular without eval, would be safe enough.
Yeah.
But the tooling isn't there because people haven't ever tried to build this sort of a thing and do that sort of an analysis.
You really should talk to John Brandt at some point. That's another
Okay.
conversation, because he wrote the world's first automated refactoring tool, and it was in Smalltalk.
Yeah.
Don Roberts might have been co-writing that with him, but that was the very first, world's first automated refactoring tool was for Smalltalk, which is not a strongly typed language.
And it doesn't need to be strongly typed as a language. It needs to have tools that can do static analysis and
Yes.
identify the effects. And
Yes.
in Smalltalk, since you're always sitting in the runtime, the tools do the static analysis and can tell you what's going
yeah,
on.
but-
And you got what you need.
But Python, languages like Python or, well, Perl or other things like that.
Yeah, it'd get really fun.
Another dimension. Okay, very cool.
Whereas a language like Haskell, it's just built in, right?
Yeah,
It'd be real
yeah.
easy, right?
And so, do you anticipate creating automated tools for these recipes?
I'm not. I mean, there are already, I'm not the first one on the scene with these sorts of recipes.
Yeah.
In fact, VS Code, a number of or Visual Studio, the main one, a lot of the refactorings there are built on bulletproof recipes like this. It's one of the differences between ReSharper and Visual Studio.
And Microsoft's refactorings.
Yeah,
Okay.
when they were building Visual Studio 2015, they were looking at their code base, or their install base, and they found most users don't have any unit tests, don't have anything, right? And they wanted to do refactoring, and they're selling to big enterprises who aren't going to trust anything and aren't going to trust the tools. And so their perspective was, we need to ensure that no refactoring ever introduces a bug, ever. If it refuses to run sometimes, that's acceptable. If it doesn't even tell people why it refuses to run, but it just doesn't, okay, that's not as good, but no bug ever, right? And so they were really pedantic and careful. And there are still bugs in their system, but they're all designed that way, and they fix the bugs, right?
Gotcha.
And JetBrains has a mix, right?
Yes.
Some of them are real safe like that, and some of them are really handy, but they're not quite as safe, so that they can operate on code, and they'll work most of the time, but you can do more things, right?
It's really interesting, because I've been wanting us to go further with refactoring tools, to do more that would enable us to just move faster.
Yeah.
Which is basically like working on the existing set of refactorings and making them even more sophisticated. What you're doing is going the other direction and saying, wait a minute, let's get to the core of what these automated refactorings do and make sure they're extraordinarily safe, so that, again, you don't need the tests. And writing tests is a lot of work. I mean, everyone says we can't do this because we have no tests. So this is huge. This is huge. So are you going to be covering things like pull-up method, push-down method, and all the various, I mean, there's a lot of refactorings in Martin Fowler's book. Right?
There are. And honestly, different refactorings get used to a different degree, and for different purposes.
Sure.
We're at Tableau, we've focused on the core refactorings, and some of them are the ones that people are used to, like extract method, and some of them are even more simple, like introduce braces. Like when you're in a C++ code base, introducing curly braces around something is actually a potentially semantics changing operation. And so there you need to be able to check for what do I need to check in order to do that safely. And the recipe mostly consists of look for this or this or this or this or this.
Right.
Okay, you can safely introduce your braces, right?
So very very language specific.
Very language specific.
Very idiomatic to that language and micro. Almost.
And very micro, yeah. And so the core refactorings, rename, extract method, introduce variable, the core 6, and a few of the basic set-based refactorings. So introduce class or create parameter object or move method, that are for manipulating classes. A couple of those, do get used very commonly, and those would be the places that I would start. But it's, again, not, I have a plan or a mission. It's the things that we need.
Yeah, you're doing it at your current employer and based on need. So it's actually evolving out of a real need, and you're implementing this. You're not just making this stuff up.
Right. And talking with a bunch of people after the talk, there was interest in, a number of people expressed interest in contributing to some of these, because we have a few more recipes inside the company that are not safe yet, right? That we've been playing around with. We've got some things, and then other languages that are just like, we just don't have one. So I'm thinking to put together a project on GitHub, on my GitHub, that'll be for these recipes, and then take contributions. And then also, Fowler is doing the second edition of his book.
Yes.
And that book is going to be primarily a web-based catalog with a print book as the second alternate. And so I've talked with him about doing some of these ultra-safe refactorings on that, and we haven't really decided yet, but he expressed a lot of interest in maybe having like a second category for these, because they aren't as generally applicable as his core ones, but they're really bulletproof, and so then you can do that trade-off and know in your circumstance which one to use.
I love it. Okay, excellent. Yeah, so I think you mentioned something earlier about making safety prerequisite, about hazard analysis. What was that?
Yeah, okay. So that's another thing that we're doing at Tableaux. It's called safeguarding. And it's in an effort to help teams get better at quality. We're trying, on the process towards continuous delivery and all that sort of stuff. All teams have a defect stream. Right? There's bugs that are coming in based off of some of their own work, based off of prior work, based off of things they inherited from other parts of the code base, the usual, right? And at the rate of defects being written today, doing continuous delivery is very, very difficult and would be painful on our customers, right? And so we need to get that quality under control. And so what teams are doing is analyzing their defect stream to see what problems are there. And this is after you do the fix. Safeguarding consists of two parts, an RCA and then a remediation. And with the root cause analysis, the RCA, you look beyond the fix to what were the circumstances that caused a well-intentioned developer human to not catch this mistake.
Yes.
And the perspective is that the system creates mistakes, and developers correct for some amount of those, and they miss some, right? And it's those hazards, and that's the safety thinking. Is it's really those hazards in the system that are creating those errors, and so we use the errors to detect what the hazard was, and then the second part is remediation. So a small time box to go in and fix those remediations. And that time box is required to be spent in the same sprint as the bug fix, and it's the same priority as the bug fix. So if you have a ship blocking bug, then you have a ship blocking hazard. Okay. You can't work on other things. If you have a P3 bug, then you have a P3 hazard. And you can work on some other stuff and get around to it or not, right?
And time box for a hazard remediation is what?
I recommend that each remediation be an hour or less, and then you set your time box based off of the severity of the issue and the probability of recurrence. And so it might be a half day, it might be 2 days, and then you'll just do a number of remediations until your time box expires.
Fair enough. Good deal. Yeah, so that sounds excellent. Yeah. We definitely do a lot of this at Industrial Logic. We're constantly, but we're moving away from we've moved away from sprints a long time ago. So it's up to the developers to decide, is this more important than working on the feature to get rid of this hazard? Recently, we've been simplifying our code base for our e-learning without adding any new behavior. So for example, we had an advanced installer producing MSIs.
Right.
And so it's a whole bunch of stuff around all that.
That's crazy,
We got rid of it all because this was years ago. We needed MSIs because people didn't have it on Windows. Windows didn't come with unzip.
Yeah.
And they would complain that they didn't have that. So we're like, okay, we'll provide you MSIs. You won't need an unzipping feature. But today's Windows, everyone has it built in. So we realized we could get rid of gobs and gobs of code and stuff that creates MSIs and just go back to zips. And it removed tons of complexity. Plus the learning curve of learning advanced installer and learning all, it's gone.
Right.
That's just an example of ongoing devotion to simplicity. Like fewer moving parts is going to be probably safer, fewer hazards.
Yeah.
So being driven by values like that help.
Yeah. And you can do it driven by values. We're choosing to do it driven by data. Which is another of the big interesting innovations, because there had been efforts to do it driven on values, but that was susceptible to the context of the moment, to the management feel at the moment, to the trade-offs that dev teams are making based off of, I don't want to be the developer that prevents my other co-developers from shipping the feature, and so even if the manager is telling me to slow down and be safe, it's like, no, I'm actually more responsible to my peers than I am to you, so I'm going to ship some crap here.
Incredible right. Peer pressure. Some of the peer pressure.
It's real, and it's actually even a socially good and right choice. Like I'm doing right by my team, except maybe we should change the definition of right. But I'm doing right by my team,
but adding the next new hazards.
Adding some more hazards, right? So by us focusing on the data. It's less susceptible to a lot of those, and it's just like bugs. They cost us money. They piss off customers. Let's stop having them.
Do you guys do test-driven development?
Yeah.
Okay, so that's also happening. Well, that's great. I mean, you are a living, breathing example of making safety a prerequisite. I know in a lot of areas of what you do. So, do you use any of these other principles?
Yes.
Experiment and learn rapidly. I think that's
definitely experiment and learn rapidly as much as I can.
You're constantly experimenting. I know this always, right?
Yeah. I mean, all of these techniques, all of the things that we're doing, the way that we're learning to refactor, the way that we're thinking of refactoring, those undergo many changes a year. The way that I teach refactoring has changed fundamentally 4 or 5 times in the last 12 months. And that's since we last talked, right? Where it changed a whole bunch of times during that period.
Yeah,
right.
That's remarkable.
Yeah.
And then deliver value continuously.
So there's 2 levels on that. Me personally, again, when working internally and with the teams, everything is always ship first and then get it right by the 3rd or 4th team, right? Yeah. Especially nice being an internal employee, I get to do that. I don't have to have the first shipment must work or I lose the contract. I can agree with everybody. We're going to go early and you guys are the pilot. We're going to figure this out, right? And then the next level, of course, is Tableau's one of our big technical goals right now is to get to continuous delivery.
Yes.
All of that.
Yep. Whole another conversation,
Yeah, and the Make People Awesome. Make People Awesome is an interesting one for me because on one sense, I do a lot of it unconsciously, apparently. On another sense, I pay 0 attention to it whatsoever.
You're doing these other 3 things, which if you do those other 3 things, other 3 principles, that's probably falling out of it.
Yeah, I think that's pretty accurate. I know Tableau as a company focuses a lot on the Make People Awesome. All the efforts on user-centered, the design for that stuff and research on data science on it's not just how do we get better data science, but how do we make it so that humans visually interpret this data in a useful and correct way?
So Tableau creates visualizations of data for people, right?
Yeah, help people see and understand their data.
Yeah, that's beautiful. Well, I think we're out of time. It's the
Cool.
conference
Thank you
party is
very
about
much.
to start, isn't
Yes,
it?
we got to get over there, and there's whiskey to be drunk.
Thank you all for
Thank you very
thank you
much.
for coming on the show.
Thank you.
Always a pleasure, and hopefully we'll talk again. And look forward to seeing what results from what you're doing, and support it in any way I can. So
Awesome.
and thanks for watching the show. If you like the show, please share it with others, and we'll see you next time.
And if you're interested in learning more about refactoring, I'm happy to teach and help people. Reach out to me on Twitter at Arlo Belshee.
I'll post that on the video.
Okay, thank you very much.
All right. See y'all.